Hey, welcome today. So today I'm going to be discussing an interesting sorting algorithm from my programming um, classes, I guess. Um, it's pretty simple. It'll be pretty helpful if you're interested in this kind of thing. Um, Basically, it's an interesting algorithm. Well, it'll cut an array or set, you could say, in half. And basically, it'll cut it in half and either go left or right depending on how close to the target the middle value you're looking for is. Now, basically, this will only work with sorted algorithms or sorted lists solely, so keep that in mind. And that this is a very fast program actually. It runs an O log of n times because each time the loop goes through, it'll basically cut in half how many times the loop needs to run. So I'll actually show you this as we go through and we look at it. So first thing we're going to do is we're actually going to write this in C in Visual Studio's code. So we're going to include the standard library. Oh, there we go, standard library. And we're going to include assaults, which are just going to help us test. So the first thing let's do is let's just create our main function. And this is just going to be for testing. So we're just going to have an int array. This is just going to be our list of numbers, and I'll do that now. So 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to end that. And then the length, we're also going to include the length of the array. So int len equals 8. Because it goes up by till 8. Obviously, you can see that. Some of you might say, well, always start with 0 elements, and like the first element is represented by a 0. But don't worry, we'll deal with that actually within the function. And we're going to go for a target, which we're going to make this 2, because why not? So we're going to come up here, and we're going to go, we're going to make all binary search function. So binary search. And what we're going to want to include in here is we're going to want to include the array that we're going to be working with. We're going to want to include the length that we've mentioned, so int len, and we're going to want to include that target variable. And then we're going to go up like this, and then we're going to need the very last element of the array, or the last element's position number. So we're going to call that high, and that's actually going to be equal to len minus 1. And it's len minus 1 because, as mentioned before, arrays in C at least start at 0, so it's going to have to be less than what it should be realistically. And then int low is going to equal 0 because that's what it starts at. And then we're going to need int middle, but we're not actually going to declare this to anything yet because we're going to be doing this in the function. So we're actually going to use a while loop here, and this is because we don't know how many times the loop is going to run. We could potentially use a for loop, but it's just simple to do it this way. So it's just going to be low is less than or equal to high, because low should always be less than high, unless in really bad cases, but it should be fine. Also, we're going to put a return value down here of -1, because that just means false, but you know what? Just to clarify things even further, we're going to include stdbool, which is basically the C library for making you be able to write things true or false. So we're just going to return false. Now, the very most important thing about this is middle. So middle is going to equal high plus low. Oops, misspelling. Oh my gosh. Okay, there we go. High plus low divided by 2, and that's going to give us our center element. And since the integers, it'll just round off, which is super nice. So the first thing I'm going to check is if, oops, too many brackets, if all middle element that we just calculated is equal to the, oh my gosh, equal to the value we're looking for. And if it is, we want to return that middle value. Now, in our case, this isn't going to be true, So we're actually going to have to keep going. We're going to have to go, okay, so the middle value is not that. So what we're going to do is if the middle value is greater than x, is greater than x, what are we going to do? Well, we're going to think about this. We're going to be like, okay, well, we need to split this away up a bit. So the easiest way is to make low equal to the mid plus 1. And this is just going to make it so instead of looking at just the whole way, we're just going to be looking at the light half of it, because we're moving the very beginning of the way to the halfway point. We're not actually showing the way or anything, but we're only looking at certain parts now. And then we're also going to do an else. This is just the opposite if the middle is less than x, and basically that's just going to be the opposite of what we did last time. It's going to be high is equal to middle minus 1, because we don't want to look at the right side this time. We want to look at the left side. And basically, this should do it. And what we're going to do, really, is we're going to go down here and use that assort function I mentioned earlier, and we're going to go binary search equals a, 1, and x. And it's going to equal 1, because if you look up here, this is the 0 element, and this is the first element. And what we're looking for is 2, which is the first element. So if I did everything right, which I hope I did, it should work. Okay, that is never a good sign. So I'm assuming I did that wrong. And there you go. Yeah, so basically my mistake was simply that for basically the low/mid value, I could have fixed this by moving this here, because I put, I should have moved the high value over to the middle value instead of moving the middle value over to, the low value over to the middle value. Simple mistake, pretty easy to fix. And that's why assault's also good, because they let you know that you made a mistake. So let's do a second test. Like, let's make sure this really works. So we're just gonna copy all of this. I'm gonna go down here, and we're gonna get rid of some elements. I'm gonna make 100 here, and this is just gonna be equal to 1, 2, 3, 4, and let's look for the 100, right? So this should be the 1, 2, no, sorry, the 0, 1, 2, third. It should be the third element, or the fourth element, but the third position. So, and then we're gonna check this again. Okay. Oh, it's because I should have done this, so just add these in, so it's not the same. I was confusing the computer. We're gonna look again, and if I did it right, there you go, it worked. So yeah, it'll work with even the edge cases. So if we're looking at the very far one way, and as you can see, this still works because it's sorted. So it goes 1, 6, 7, 100, smallest to biggest. And I'm sure you could do it biggest to smallest, but you'd have to, I think you'd have to just change these values around, but realistically this set works. So I'm actually gonna, let's write this out. So basically we're starting with 1, so basically we're starting with 1, 6, 7, 100. And then we're gonna look at this, and the middle value here would probably be, so 1 plus 100, and let's open a little calculator. 101 divided by 2, 50.5, and this is going to round down to 50, which basically just means it's going to go to the 6. And is 6 the correct element? No. So we're going to add 1 to low. So then low is going to equal the middle, so 6, plus 1. So basically, the middle is going to become 7 then. And is that the correct element? No. So then we're going to add these two together, and it's basically just going to round up to be 100 after, because basically at this point it'll be 7 and 100. And basically, if you look at these, it's going to be like, okay, the middle value is 7, but it's clearly not what we're looking for. We're looking for 100, so it's just going to basically make the low value this position plus 1, which is 100, and then we're going to check if 100 is equal to 100, which it is. So we have our answer. It's 100, it's position number 3. And that is binary search in a nutshell, basically. It's pretty easy to implement. You can use this with all kinds of things, including ASCII values and things. Also, if you look at this, you notice it goes from it runs as long as roll to high, but it also divides by 2 each time. So realistically, you're cutting in half the amount of elements you're looking at each time. And this basically gets more and more effective the bigger the array gets, because when it's small, it'll be pretty similar to other ones, but the running time really is pretty good for this sorting algorithm. Yeah, so thanks for listening. Thought this was kind of interesting to go over, and it's only like, this algorithm is literally, let's take a look. Let's go with some of these useful spaces, is only like, doing some quick math, 21 lines, which is really quite simple. And it's super effective. So if you ever need a quick sorting algorithm, use this. Also, if you're trying to get in the CS and you're looking at algorithms, this is a helpful video just to learn about it. Anyway, thank you. Have a nice day.